Hello, welcome. We're looking at Chapter 6, Section 5, specifically applying systems of linear equations. Application problems are like a euphemism for saying word problems, but they're word problems because they're explaining a scenario, and in that scenario we'll get some information that will help us to make equations and solve it, which is the whole point of what we're going to do here. So this is the second of the videos for this section. The first one was about choosing the right system when you see the equations. And you can look at that one separately anytime you want. We're going to consider this part 2, and it's going to be the first one with the word problems here. So let's look at this one. We have a roadside vegetable stands selling pumpkins, and they are $5 each. And squash, or squashes, I think squash is the better term because I think it's plural, whether it's plural and singular, I think both are squash. But squashes make sense too. $3 each. Well, one day they sold 6 more squash than pumpkins, and their sales totaled this amount of money. We are going to write and solve a system of equations to find out how many of both of these they sold. So the first thing you need to do is identify your variables, okay? And I'm going to choose an x and a y. I could use p and s, but besides the fact that s's and my 2's tend to look too much alike, I am simply going to say I'm too used to using x and y. So I'm going to say that x is the number of pumpkins and y is the number of squash. And then I'm going to see, well, each pumpkin was $5 each. So $5 times x is the amount of money you get for the pumpkins, and $3 times y is the amount of money you get for the squash. And that's what helps with this part about $98. We got $98 from selling some pumpkins at $5 each and some squash at $3 each. So it's 5 times x plus 3 times y. That is the amount of money we got, which is $98. Ooh, cool. Okay, so we've got something to work with. We already have here now one of the two equations. For the other one, there's a couple of ways to think about it. You can possibly even understand it, immediately by yourself on here. But I have a mathematical way to look at it and think about it. What I'm going to do is I'm going to make an XY table, and I'm going to play with some scenarios on it. This will be pumpkins, this will be squash. Okay, so here, let's just start off with a number for one of them, 1 for x. If there's 1 pumpkin, how many squash? Well, it says there were 6 more squash than pumpkins, so 1 plus 6 is 7. If I did it the other way and said there was 1 squash, well, there's more squash than pumpkins, so we'd have to go down from that. We'd end up at like -6. That doesn't make sense. We're not going to pay people to take our pumpkins. So if we were the owners there, so that doesn't make sense. So I wouldn't use a 1. But then let's do the next of these. Move this up a bit. Let's say I put a 2. Well, if there were 2 pumpkins, that would mean that there were, plus 6 would be 8 of them, wouldn't it? Okay. 2, 6, 8. Yeah, that makes sense. If there were 3 of them, we'd add 6 and we'd get to 9. And 4, 5, 10, however, let's say we had 10 of them. 10 of them plus 6 would give 16. But in every case, we're adding 6. So what this is the x. If we wrote it algebraically, we'd come down here and we'd say if there's x of them, we would do x plus 6. And so now we know a relationship here between these. Okay, oops, I shouldn't say x plus 6. It's y plus 6. Where's my little eraser thing on here? The number of pumpkins is equal to y, which is the squash, plus 6. So it's x equals y plus 6, and x equals whoops, I think I have that wrong. Hold on. It's plus 6, the number of pumpkins plus 6. No, that sounds right, doesn't it? Ah, but you know what I just did is I put the plus 6 here wrong. See how it's possible to still sort of mess up exactly what's happening? So let's rethink this here. It's plus 6, but it's this one plus 6. So when I started down here, I got a little too happy with trying to do the y's. It's this number, let's put it with the 10. 10 plus 6 is equal to 16. Well, if the 10 is the x here, then that would be the x and this would be the y. And so it's x plus 6 equals y. I could do that with each one of these. This would be 1 plus 6 equals 7, which is x plus 6 equals 7, and there's the plus 6. Here, let's do it with a 3. 3 plus 6 is equal to 9. The 3 is the number of pumpkins, plus 6 equals y for the squash. So it's x plus 6 equals y, so you can put any number in for x now. 100 pumpkins would mean 106 squash. So back up here, I am going to say that it's x plus 6 is equal to y. Or we could say y is equal to x plus 6, either way. What we have now is we have two equations. And now I was very careful to look back and fix this one, and I know it's correct. That means if this is y and the other part means this, I can just simply plug it in here and I have a substitution. I'm going to say 5x plus 3, substitute x plus 6, because that's y, is equal to 98. And now you do the mathematical parts of this in order to solve it. 3 times x plus 3 times 6 is 18. These two are on the same side, so we would add them together. 5 of them and 3 of them makes 8 of them. So 8 pumpkins plus 18, what, dollars, whatever. Yeah, dollars would be, is 98. Subtract 18. And 8x is equal to 80. Oh, it turns out when we divide by 8 here, that x is equal to 10. And that's just like we had in one of the ones that we did here without my realizing it or thinking about it. I put 10 in for pumpkins once and figured out it would be 16. And we know that from here, 10 plus 6 equals 16. So it's 10 pumpkins and 16 squash. And we have answered the problem. We did two equations, a system of equations, and then we found out how many pumpkins and how many squash they sold. Now, that's one scenario. With money, you can often put the money together in a way to make an equation. Let's take a look at this one, which is another income problem. Ramiro earns $20 per hour during the week, $30 per hour for overtime on the weekends. 1 week he earns $650. And then we've got some more stuff to read. Works 5 times as many hours during the week as he did on the weekend. Interesting there. We are going to write and solve a system of equations. So let's get that system of equations, and then we will look at this. We'll look at this part for one of the equations. We'll look at this part for the first one. This part and this part. So the amount of time he worked on the week, the number of hours on the week, and the number of hours on the weekend. Well, that's what we need to find because we want to know the answers to the weekend ones. So we need an x and a y, and we don't know how many hours on the week, and we don't know how many hours on the weekend. So we're going to choose those for the x's here. And I'll write it out like I did on the last one, where x equals hours during the week, y equals hours on weekend. Okay, so now we have that settled for what they are. Let's think about the amount of money here. We have $20, so during the week he gets $20 for every hour during the week, so that's 20 times x. And on the weekend he gets paid more because he's taking, it would be his own personal time. So $20 and $30. however many hours on the week and however many hours on the weekend. When he's paid all that, he's paid for $650. So let's put $20 times however many hours, whatever it comes to, plus $30 times however much it is on the weekend, the Y. Oh, I put an X here and it should be a Y. So here, 20X plus 30Y is equal to the $650. Let's make that a better 3 here. Okay, so now we have one equation, and we don't need the dollar signs for them, even though it's sort of nice to put them in. But once we're just solving it algebraically, we wouldn't use those units. The other one is he worked 5 times as many hours during the week as he did on the weekend. So let's do an X and a Y. So this is week days and weekend here. So let's start off with it should be hours. Hours during the days, hours on the weekend. Well, here's the thing. Nobody works just 1 hour. Let's make it a more reasonable. Say it was 8 hours a day. So if it was 8 hours a day, okay, then this is during the week. He only works 8 hours. On the weekend, well, he worked this is 5 hours, 5 times as much as whatever this is. So that means if we wanted to take the number of hours, we'd have to go down. We'd have to do like some number divided by 5. Well, I don't like that. Let's instead do it the other way here. I'm going to try it with the 8 here. Let's say he works 8 hours on the weekend. Well, it says 5 times as many during the week. So we'd take this and we'd multiply by 5 and go this way. So it would be 8 times 5 is, 40 hours. So that would be 40 hours he works on the weekdays, and then he works 8 hours on the weekend. So it's like 1/5 of it. Yeah, it does make sense. It would be less time on the weekends. So let's say it was 10 hours here. Then we would do multiplying by 5, and we would get to 50 here. So what's happening is that what we do on this side leads to this one over here. So whatever this is would be our Y. We would multiply it by 5 to get it equal to that X. And that gives us our other equation, except we don't use an X for times anymore now that you're at this level of math. So it's 5 times Y, and that means we have our second equation. It is not required to do something like a table of values, but it's often helpful because you see how I sort of showed that you have to try to figure out if it's this number, what would it be for the other, what would make sense based on the 5 times part. And then I got to the point where I could see that every time I had a number on this side, I'd multiply by 5. Here, multiply by 5. If I did 100, I'd multiply by 5 and get 500. And it was always the Y that I would then multiply to. And the result would be the X. And that's what this shows here, is I multiply 5 times whatever the Y is, and it gives me back that X. And I now have 2 equations, and this looks very much like a substitution. Here's an X, here's an X. It looks like I'm going to put 5Y into there because I'm going to substitute that. So, whoops, it's not 50, but 20. 20 times 5Y, that replaces the X, plus 30Y is equal to 650. Okay, 100Y plus 30Y. And then we put these together and divide by the 130. Okay, and that means the Y comes out actually to the number 5. So we get that if that's 5, so Y would be 5 and X would be 5 times 5. So that's the number of hours that we worked on the weekend and on the weekday. And the question was just the weekend. So the answer would be he worked 5 hours on the weekend. So I didn't even really need to figure out that X equals 25. I just like doing it. So I have here the two that are systems of equations, got them both, and I have here the result, or the number of hours that he worked on the weekend. And that's how you solve this problem. Very similar to the first one, just a little twist with the x and the y there on it, and the wording of the equation. Now let's take a look at a third one here. Okay. Anya made 14 baskets during her game. Some of these baskets worth 2 points and others worth 3 points. Okay? If you know and like basketball, even if you don't like it, if you know basketball at all, you know there's 2-point shots and 3-point shots. And in total, she scored 30 points. Write and solve a system of equations to find how many 2-point baskets she made. 30 points is pretty good. Okay? Well, x equals, and I can be that for either one of these. I think I'll just do the 2-point baskets, because it makes sense that that's one of the things I need to know, is how many 2-point baskets she made. Y will be how many 3-point baskets. Okay. So the number of points that you get, we'll do it this way. The number of points for 2-point baskets is going to be written as 2 times x, because x is the number of baskets. And for 3-point baskets, it's going to be 3 times y. And that does make sense. Well, we know that she scored 30 points. So at some point, she did a certain number of 2-point baskets at 2 points each, plus a certain number of 3-point baskets at 3 points each, and that gave her a total of 30 points. All right, that works really well to understand that. That does make sense. If you know sports at all, especially basketball, that really helps. That's an easy one. Well, sort of. We also know this, that she made 14 baskets total, and that has nothing to do with how many points. That's just how many x and how many y. So that means the number of one type of basket plus the number of the other type of basket is 14. And we have a system of equations. That's one of the nice easy ones to write up. And sometimes you'll see that where there's like just a total that you get. Okay, that's meant to be a star here. There, okay, that works. Well, now I have the two equations, and now I should solve them to find out how many 2-point baskets. And this looks very much like I can do this one either as a substitution or as an elimination. With both an x and y being 1s, I'd say substitution is the sort of the easiest way to go, except that I still like doing the elimination. So I'm going to take this one and I'm going to multiply everything in it by 2. That gives me 2x plus 2y. Actually, I'm going to change that. I'm going to multiply it by negative y, because I like doing adding at the end. So if I multiply negative 2 times each one of these things, I get a negative 2x. Negative 2 times y is negative 2y, and negative 2 times 14 is negative 28. And then I'm going to take this one and put it underneath. 2x plus 3y is equal to 30. And now I can add the two equations instead of subtracting. And that goes away. Negative 2y plus 3y is just 1y. And 30 take away 28 is 2. Y is equal to 2. And y was the 3-point baskets. So if I want to know how many 2-point baskets, I'd use this equation. And so I have number of 2-point baskets plus the number of 3-point baskets is 14. I now know that y is 2, so x plus 2 is 14. Subtract 2, x is equal to 12. So 12 2-point baskets. That is our answer, what they're asking for. So it was write a system of two equations and then solve it to find out how many 2-point baskets, and so the answer is 12. Okay? And that's how you do this type of problem. Nice easy one with basketball, but it still requires the basic things here of you have to be able to make two equations and then use one of the methods to solve it. If you're a person who likes substitution and you wanted to make this one here as x equals negative y plus 14, and then take that and put it inside of x here, you're welcome to do that. But this time I like doing the elimination, and sometimes it does seem easier. Classically, though, we'd say that because the x and y both have coefficients of 1, that means substitution would usually be the quote-unquote best method. All right, now that is 3 of the examples for this section. The next video will have the other 3 examples that I have prepared for this section. So that will be part 3. This is the part 2 video, that's the part 3 video. And remember, the part 1 video is showing some examples about choosing which is the best method to solve those examples. Thank you for watching. I hope this was helpful.